6.2, displaying and organization of data. So when describing a numerical data set, you're going to include these 4 pieces of information. I don't know why that happened. There we go. Try that again. Shape, outliers, which are unusual values, center, whether it's the mean or the median, and spread, how it's spread out. And we're going to use the acronym SOPS. Or if you're a fan of The Outsider, SOCIALS. Outsiders, not outsider. Okay, let's talk about the center. 2 common measures of the center of data. The mean, which is the average. You add up the numbers and divide by the total number, or the number of data. Then the median is when the data is listed numerically in order, smallest to biggest. The median is in the middle of the data. When you compare the mean versus the median, it will give the data its shape. So the shape of a distribution can be determined by making a data display. Now, numerical data can be organized as a histogram or a histograph. You can use either term, which is a bar graph, sort of. A stem and leaf plot. Now, just real quickly, just for a sample. The reason this is like a bar graph, but it's a little bit different, is they are all touching. And the data is based on ranges, not specific numbers. I'll get more into that. A stem and leaf plot is when you put all the tens, like this, and then you put all the ones here. So this is 91, 93, 95, 80, 87, 89, 70, 70, 71, 72, and so forth. This whole thing was supposed to be stem and leaf plot. And then box and whisker, or just called a box plot. So box plot or box and whisker, that's where funky are. And a box plot looks something like this, where you have your low value, you have your high value, you have your middle number, and what we'll get into later, this is called Q1 and Q3, quartiles. And technically the median is Q2. Okay? So that's the different types you might see. Now, categorical data, such as eye color, or favorite band, or favorite animal, can be organized into a pie graph, or a circle graph. Now, the shape can be determined by looking at the graph of the data. There are 4 basic shapes of numerical data. The uniform distribution basically looks like a rectangle. So, all your data looks like this. A symmetrical looks like this. It's also known as a bell curve. Okay? Now, for both of these, the mean is equal to the median. That's very important. For a normal distribution and for uniform distributions, they're the same. They're equal to each other. Now, if you have a skewed left, it looks like this. And in this case, the mean is greater than the median. And then skewed right, sorry, put it backwards. I can read my own writing. The mean is less than the median, and here the mean is greater than the median. A lot of people get skewed left and right backwards. Think about this. Think about where the majority of the data is, and then what is pulling away from that. And that's the data, here. So in other words, like most people did really well in this test, and a few people didn't do so well. The people who did not do it as well are pulling the data down to the left. And if most people did poorly on a test, but a few people did really well, that is actually increasing, pulling everything to the right. So that's one way to look at it. Find out where the bulk of it is, and then find the tail. Follow the tail, basically. Okay, so determine the shape of the graph and whether the mean is greater than the median. Well, on this one, if you kind of look at it like this, where is the bulk of the information? The bulk of the information, the bulk of the data is to the right, okay? But there are a few down here pulling to the left. So that is skewed left. In that case, the mean is less than the median. So the average is being pulled down by those few on the left. Here, we have a pretty symmetrical or normal distribution. Okay. Either one's fine. You can put symmetrical or normal. Right here, what do we have? Everything is the same. Means equal to the median, and that is uniform distribution. If we look here, where's the bulk of the data? It's down to the left, but these 1, 2, 3, 4, 5 pieces are pulling to the right. So they're actually increasing the average and pulling to the right, so it's skewed right. All right. Now, two common measures of spread are range and standard deviation. So the distance between the highest and the lowest number of the data set is the range. The standard deviation is how, on average, how far are you away from the mean. And there's actually a video you can go to if you want to watch it. Now, using the calculator, to find the mean, median, standard deviation, and interquartile range, that's what that video is for, IQR, using the graphing calculator. So this is going to take you through step by step, and we're going to practice this in class. So pretty much here you just have to watch. So, for example, well, that's not where I wanted it. Okay, so we turn it on. We're going to press Stat. We're choosing Edit. And you're literally just going to put these numbers in. Okay? And just watch. 24, 27, 19, 46. If you want to fast forward a little bit, you can. 51, 33, 39, 13. And you always want to double check as you're entering them to make sure you don't make a mistake. 30, 45. Sometimes the buttons stick. 14, 28, 32, 36, and 41. So there's our data. Now, Second step, calculate. So we're going to press stat, go over here to calculate, and we're going to choose one variable statistics, and we're going to tell it to look in L1. And tell it to calculate. And there you go. Now, this is all the information. You can see it scrolls down, more stuff. Okay? So there's a breakdown of your notes of what these things mean. Alright? Now, X with the bar over it is the average. Okay? This funky looking EX is just all the numbers added up. And EX squared is all those numbers squared, added up, squared. Not a big deal. That's the way to get to the standard deviation. Now notice there's two types of standard deviation here. SX and a funky OX. OX, you can see in the right of your paper, is the population. And SX is the sample standard deviation. And we'll talk about the use of those. Now, number is 15, so we put in 15 pieces of data. And if you scroll down, this is known, as you see in your paper, as the 5-number set summary. The minimum, Q1, median, Q3, and max. If you remember, that's how we made that box and whisker plot earlier in the notes. So, what was the minimum value? It was 13. The maximum value was 51. The median was 32. And the average, very first number we saw, 31.9. Now, the standard deviation, we're going to go with 11.1. We're going with the sample standard deviation, right here. It actually should be, no, I'm sorry, we're going with the population. 11.1. 0.06 rounds to 0.1. And then the IQR, which is just Q3, whoops, Q3, 41, minus Q1, 24. So 41 minus 24 gives us 17. And then how do we write the 5-number summary? We just write those numbers like so. 13, 24, 32, 41, and 51. Just like that. That's supposed to be a bracket out of 3. And so what a box plot would look like is, with those numbers, whoops, that was not supposed to happen. So if I have these spaced out, 10, 15, 20, like so. And I put my values. 13 would be about here. 24 would be right about here. 32, right about so. 41, right about here. And 51, right about here. Okay? Well, that would be my box and whisker plot. Here's my low. Here's my high. And it looks like that. So 25% of my data is here, 25% here, 25% here, 25% here. That's why they're called quartiles. Just like 25 cents, 4 quarters, and $1. Okay, we're almost done. Example 2, mother's ages when they had a baby. So again, you would enter all these in your calculator. I'm not going to show it to you again, we'll practice in the class. But you would go to stat, enter all these in L1. Now let me show you one little trick though. Let's say I'm going to go back and do this, and I want to redo this. Instead of writing over these and deleting them one at a time, there's a quick trick. Go up here and just hit delete. And then boom, you're ready to enter all your data. Now, again, I'm not going to do that for you. But you'd enter all this, you'd run your statistics, and here's what you would get. Your minimum would be 28. Your maximum is 39. The median was 30.5. 31.5 for the mean. The standard deviation, 2.68. And this would be 32.5 minus 29 with an interquartile range of 3.5. Now, if we want to see this as a histogram, I will put it in the calculator and just run it for you. So here's the data and the 5-number summary. Like I said, I would run it for you to show you what it's already like. Now, to make a histogram, okay, it's actually not on here in the instructions completely. What you want to do is you're going to hit second stat. And we're going to go here to 1. Now it matches your screen. Okay? Oh, it is on there. So, sorry, it does say go to stat plot, second y equals. I missed that part. So, we want it to match this. We're going to go, it's on. We're going to go down here and go over to that box thing. It looks like a histogram. Okay? Now I have to make one change because in mine, I actually added into 2, so I need to look at L2. You choose the box plot. It's at L2. And now notice how it says, to make it show up the way we want to see it, we're going to hit zoom, stat. So here's zoom up here. Stat 9. That's not right. Sorry, but it's wrong. We're going to go to zoom, and we're going to go down to 9, which is zoom stat. So there you go. That's how you would draw it on here. And then it says press trace. That's this button right here. And you'll see where it says from 28 to 30.2, there's 10. And then going right from 30.2 to 32.4, there's 5. Then there's 3 here. There's 1 here. 0 here. And 1 there. So if we're going to sketch that on here, you can put your numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then again from 28 to just past 30, 30.2, there's 10. And then from 30.2 to 32.4, there's 5. So 1, 2, 3, 4, 5. 32.4 would be about there. And then 34.6, there's 3. So a little bit past 34.5. And then up to 36.8, almost 37, there's only 1. And then up to 39, there's 0. And then at 39 to 41.2, there's 1. That's what it would look like. And then last but not least, if we wanted to run a box plot, we do the same thing. So we go to second Y, hit enter, and now we're going to go to a box plot. We're choosing this first one right here. And then we're going to hit zoom stat 9 again. And you know what these numbers are, but there you go, 28, 29, 30.5, 32.5, and 35. And we got that from our summary. So if we're going to sketch that, at 28 is our minimum, 29 is our next one, 30.5 about here, 32.5 about here, and 35 the end. So we just go through like this, and there's our box and whisker. And that's it.